Hey guys, this is Mitch with FinePoint CGI, and today we're going to talk about refactoring our player controller for our Godot 2D platformer series. Now this is a very dry subject, it's a very long video, so I understand if you guys don't really want to watch it, so I did leave a link to the code in the description below so you guys can just have it. But I do go over basically state machines, and I do go over, ternary operators and compacting your code and things like that. So I do talk a little bit about maintainability and things like that. So if you guys want to hear all that and kind of follow along, you're welcome to. But that's what I have in store for you guys today. So let's go ahead and get started. Okay, so the first thing that we're going to do is we're going to talk about refactoring our player controller. So if we head over to our player controller here and we kind of take a look at some of the code, it's a little on the messy side. So we have a lot of ifs here, we have a lot of if checkings, and we have a lot of, hey, am I on the floor? Can I climb? Can I dash? Am I climbing and dashing? If I'm not, then let's go ahead and do some of this stuff. Hey, how's my mana? And things like that. And a lot of this code can get refactored to be a bit cleaner. You can see we have a bunch of functions down here that some are very useful and some are kind of a mess. Now, this is what happens a lot of times when you do a game, is your code becomes kind of a pain to handle. And this is when you start expanding past a basic game and you start expanding into more of a complicated, system. So we're going to refactor some of this code and make it look better. Now, I already have the final product here. And the reason why I do, and normally I don't have the final product until I am done recording, right? I usually do all of this, on the fly and as I work. But I thought it would be good to explain to you guys how this is going to be cleaner, right? So you can see first we have an enum here, which is basically a state or a immutable value, right? And we're basically saying, hey, what is the player's state, right? And you can see we have a bunch of states here. And if we scroll down here, you can see that we actually check in a big switch statement what our state is going to be. And the reason why we do that is because we say, hey, what's our current state? And if our current state is, dashing, then let's go ahead and process our dash code. And that allows us to really quickly break down our code in a very simple way. If we were to throw a breakpoint here and we were to say, what's our current player's state? And we go, oh, it's dashing. We can guarantee you if we're having a problem, it's because that state is being weird. And that's kind of the advantage of this system. And you can see down here, we're going to have an input manager, which is basically going to handle all of our inputs. Before, we handled all of our inputs through just randomly coding it in. Whereas here, it's all going to be nice and clean. And same thing with our timers. We had them scattered throughout our code where we are resetting variables and things like that. Instead, we're going to go through and refactor it and make it a little bit better, a little bit more cleaner. And same thing with attacking, interacting. Interacting really isn't going to change too much other than I'm going to teach you guys this, which looks scary, but trust me, it's not. And yeah, so basically this is what we're going to be doing today. And let's jump into our player controller and let's go ahead and start coding it. So first we're going to scroll all the way up here to the top and we're going to go ahead and add in our states. So this is where you start deciding what your character can do. And we already kind of know what our character can do because we already have an entire character controller built. So we'll just go ahead and run right in. So we'll say we can go ahead and do an enum player state. And then we'll go ahead and say what states can we have? Well, if we're touching nothing, our player can idle, right? If our player is pressing left or right, the player is going to be moving. So we can say running or moving, if you want to call it that. They can attack. They can climb. They can dash. If they get hit, they got to take damage. They can die. And they can also wall jump. Sweet. So these are going to be the states that the player can be in, right? If I remember correctly, that's all the states. If not, we can go ahead and add some later, but this is what I'm pretty sure all of our states are. From here, we need to hold on to our current state. So let's just come down here and say public player state current state is equal to player state dot idle, and you'll see that we actually have these little states here. Now, the nice thing about this is we can actually just, instead of checking states through like strings or things like that, this gives us a guaranteed value. So there's no magic string craziness that could break our project. It forces us to be in one of these states. So I'm going to go ahead and say we're an idle state. And now what I'm going to do, and it says inconsistent accessibility. I need to make my enum public. So we'll go ahead and do that. There we go. And that'll fix that little inconsistent accessibility. Now, one of the things that we should do while we're here is we should scroll down to our physics process and start setting up all of our state management stuff. So this will be pretty simple, but basically what we're going to do is we are going to go ahead and come up here and we're going to make a switch. So you type switch, S-W-I-T-C-H, space, your little parentheses, and then you're going to say current state. And then from here, you make an open curly brace, enter. I don't think I've ever actually talked about switches too much on here, so I figured it would be good. And now we can check for what's called cases. So we're going to do is say case player state.idle. Then we are going to go ahead and do some code. Now in our case, we don't really have any code for the player to do other than just pass, right? So we'll say break. Okay. Next, the next case that we can do is case player state dot attacking, right? Because the player could be attacking. And if they are attacking, then we want to say attack, right? Because that's something that the player, that we already have coded that the player can do. So we'll go ahead and break from there. And the reason why you do break is break breaks the switch statement. It literally comes in here, says, oh, this person's idling. I'm going to do whatever codes in between here and break. Break, I'm going to move on from this point, basically. So what's going to happen is case attacking, it's going to come into attack, it's going to run the attack code, and then it's going to break and then go to this if statement right here. Simple enough. So now we will go ahead and do the same thing. We'll hit enter and we will say case player state.climbing. And then we are going to say process climb. We'll pass in our delta because we already have some code for this. So you'll see me kind of going in and cleaning up a little bit of our code here as we go. Case player state.running. And that probably should be a capital R. I'm not sure if I like that, but we will say process movement, and then we'll pass in our delta. And you can see where we're going with this, right? So we'll just go case player state.dashing is, and if I remember correctly, we have process dash. Actually, we don't have a process dash. So since we don't have a process dash, we'll go ahead and break. And then we have case player state.taking damage. I don't have anything for taking damage, so we'll break that for now. Case player state dead. I don't have a case for that just yet, so we'll go ahead and break. And then player or case player state wall jumping. And we'll go ahead and process our wall jump because we actually have code for that. Now, this code is by default not going to work very well. And the reason why is we are not changing our current state, right? All we're doing is just idling, right? It's going to run through, it's going to hit idle, it's going to break, and then it's continue along with the rest of our code. And speaking of the rest of our code, we really don't want any of this code to exist. So what I'm going to do is I'm going to go ahead and toggle comment that, so that way it's commented out. And that's Shift-Alt-A if you guys don't know, and that will go ahead and comment all of this code out. Now, if we hit play on our project here, you'll notice that it's going to do nothing, right? We can't do anything at all. Our player is 100% frozen, unable to move, unable to jump, unable to do anything. It's not even idling. So let's go ahead and get our idling to work once again. So the first thing I'm going to do is I'm going to come in here and I'm going to say private void idle. And I should probably pass in delta. So we'll go ahead and pass in our float delta. And in our idle code, we can go ahead and figure out what were we doing during our idling, right? If you remember, when we idled, we would go ahead and do things like slow down the player. We would do things like play our animation idle, right? So if we look, let's see, there is a section here where we do play our animation idle. So you could just kind of grab that bit of code and paste it in here, which is good. But we also need to check if our velocity is bigger than X amount, right? Because we don't want them to idle for no reason, right? So what we can do is we can go ahead and say, hey, if velocity dot X is less than 5 and velocity dot X is greater than -5, then we'll go ahead and do our idle. Or else the player must have let off the key and they just kind of want to let their character coast, right? They want to let their character slow down. So we'll say velocity dot X is equal to mathf dot lerp velocity dot X comma 0 comma my friction value. And what that's going to do is that's going to allow us to slow our character down when they're running. So now if we go back to our project, you'll see when we hit play, our player is going to go ahead and start its idle animation, which is exactly what we want, right? Because our character is in its idle state currently. And apparently not. So let me see. Oh, I'm not calling it. You can see I have 0 references here. So let's call that. I should probably pay more attention to that. So we'll come up here, paste, and then get rid of that float, because if I remember correctly, my delta is the same. And then if we hit play, you'll see that our character idles. Perfect. So now that we have that, let's go ahead and hook up our input management. Now, you remember with the previous code that I showed you guys earlier, we have an input manager. And the reason why is because we are doing a lot of stuff here that honestly just isn't worth having. Okay? So what we're going to do is we will come down to our, let's see, let's grab is action pressed UI up and down. Actually, I have all of this. So let's grab all of this here. Let's copy it. Let's go ahead and make a function up here called input manager. So we'll just put it right here by our idle function. So we'll say private void input manager. And we don't really need to pass in, I don't know if we'll need to pass in delta, so we'll expect it. I don't think we'll need it, but I'm going to want to have it just in case. Let's go ahead and paste this in here. And what we're going to do is we're going to check to see if things are being done with our UI buttons. So I pulled all of this code, and the reason why is because it's just easier to have all of this code. So what we'll do is we'll say, okay, if the input button is UI left, UI right, UI up, down, dash, and this will go in order of operations here. So for instance, if input.action pressed attack, right, that is going to be read before the rest of this, right? Because we want attack to take precedence. So what I'm going to say is I'm going to say if input dot is action just pressed, quote, attack, then I want to go ahead and do my attack code. So we can say, we'll say attack first, just in case, and we'll go from there. And then we're going to go ahead and say, all right, if input dot is action just pressed, quote, switch spell, then we're going to go ahead and cycle our spells. Magic controller cycle spell, and that'll allow us just to recycle our spells. Now you'll know that this exists somewhere, right? And that's in here. So we're kind of taking this code and we're dumping it out here, so that way this little bit here isn't in my main function here, my little switch state, or my little process thread here. And what I'm going to do is I'm just going to say input manager and pass in delta. There we go. Now, what we need to do is we need to change our states, okay? So in our attack state, I think I'm going to wait to change our state to attack just to see what happens. In our cycle spell, I'm going to wait to see what goes on with that. With UI left and right, let's go ahead and say, yep, flip state, and let's change our current state. So current state is equal to player state dot running, right? I'm going to go ahead and grab this, and I'm going to go ahead and paste that, and that will work. Now I'm doing my flip direction here, flip direction Y. That's going to work just fine. And for dash, I don't want the player to have all of this code in here. So let's grab this code, and let's create a function down here called process dash, and we'll go ahead and paste that code in there. Now, this is getting kind of messy, so let's format our document, and that'll kind of format everything and make everything look a little nicer. You don't have to do that, but I just like to. But from here, we can go ahead and say, okay, our current state is equal to player state dot dashing, and that will allow us to call our dash code. Now we need to come up here and grab our dash section here to say process dash and pass in our delta. There we go. For some reason, Visual Studio is not happy with the way this is handling, but that's okay. And from here, we might be good to go. Let me come down to our process movement code. And let's rip out a bunch of code because we don't need any of this. And actually, we need this facing direction to be 0. So let's come up to our input manager and put that in like that. So that way we have our facing direction as well. And let's come down here to our process movement code. And let's just basically burn all of this. We don't need any of that at all. So we'll go ahead and rip all that out. And is there any additional code that we need to do for process movement? I think we could probably clean this up quite a bit. So you can see here we have if dashing, and we have this. We could probably clean this up because this is our dash section of our code, and I'm not a fan of that. And also we have this is not an error, but if our state is running, it shouldn't matter, right? We're in a run state, so therefore we know the player's going to run, right? So what we can do is we can go ahead and say, all right, let's open up a new tab here. Let's grab this code. Let's pull it out because I want to save it just in case. But I got a feeling that we're not going to need it. So we'll go ahead and do that. And then we will go ahead and basically refactor this a little bit. First, what we're going to do is we don't need to worry about facing direction X or Y because we know that the character is going to be pressing a button now because our state wouldn't be in process movement if that wasn't the case. So we will go ahead and rip this out. We don't need dashing anymore because we know that the player is going to be dashing, or the player is not going to be dashing because they're in the process movement section. So we'll get rid of that. We know that this is all useless because it doesn't need to be there anymore. Because if the player isn't running, why would they be in this function? We no longer need really any of this because that's all of our idle code, right? It's going back to our play idle. So we don't need any of this anymore. which means we also don't need this. And you'll notice suddenly our code just became very simple. Now, something that we do need to look at is we need to go ahead and check our velocity to make sure that's not going above a specific amount, right? Because we don't want to make our velocity suddenly be insanely high. So let's go if mathf.abs velocity.x is greater than speed, then we want to go ahead and set their velocity dot x equal to speed multiplied by the facing direction dot x, right? Because what that'll do is that'll basically just make it so the velocity is the correct velocity. I mean, simple enough, right? Now, one of the things that I don't know if I've ever explained is what mathf.abs is. And ABS is basically absolute value. So what it does is it doesn't matter if you're going negative or positive in terms of your numbers, it's going to go ahead and make that a positive number. So if it's negative 100, it becomes 100. If it's positive 100, it's 100. And it just simplifies your code by a lot. So let's go ahead and hit Control S and let's test this real quick. So in theory, with this little bit of refactoring, we should be able to press left and right. Our player should be able to run, right? Because it's going to go to current state.running. Then it's going to come up here. It's going to check process movement delta, and then it should be good to go. Now, one thing that we're missing is our ability to move. And what I mean by that is we're not running through our move and slide code, so we need to add that in. So let's go ahead and come over here and say move and slide, and then let's go say velocity, comma, vector2 dot up, and let's see if that goes well for us. So let's go back to our project here, hit play, and we should be able to go left and right. We should be able to attack in theory. So now we can go left and right. Cool. We can't jump yet. You can see that our idle animation isn't running. If we hit X, we can attack. If we hit Z, we can switch our spells. So we have some of our stuff working. So that's good news. So now let's go ahead and take a look at our idle code. So if the character lets off, they should be idling. So let's go take a look at idle. So I'm going to bring that down. And this should, if it's less than 5 or it's greater than 5, and actually we could probably just do mathf. Let's make this a little cleaner. mathf.abs velocity x is less than 5. And that will clean that up quite a bit. And one of the things that you'll notice is that when we let off of our input, it didn't transition back to idle. So we have some options here. We can either go ahead and have a if nothing's pressed, then go ahead and be current state idle. That's an option. Or we can go ahead and do a bunch of else ifs, else if, else if, else if, all the way down. But then you can't do left and right movement while you're dashing or jumping, right? Because if you press the space bar, the character's jumping. Therefore, you would think that it would not allow you to process movement, right? Because it wouldn't hit this bit of code here telling you which one your facing direction is. So I don't think that's going to work. So what we can do is at the end of our process movement, we could set our current state to idle, maybe, and see if that'll work. So let's try that. Okay, that looks like that's going to work for us. So I'm good with that. If we hit shift, you'll see that dash doesn't work yet. So let's go ahead and take a look at that and let's see if we can fix that. So we'll go up and I'm going to minimize a lot of this code because a lot of this code is just taking up way too much space. So let's make it smaller, smaller, smaller. There we go. And process dash, we do have that. And you'll see that we have it set up over here, player state dashing process dash, but you'll notice that our input manager doesn't have, well, it does have if action press dash. Am I pressing the right button? Let me make sure. Yeah, it's shift. I thought so. So let's put a breakpoint here. Let's go ahead and play this in the editor and let's see what's going on. Because I got a feeling that something's broken here. All right, so I hit shift dash. Is dash available? I'm going to assume, well, the answer is yes. Oh, I see. We're not actually setting our velocity here. So let's stop this. And then let's go ahead and set that. That's my fault. I didn't even realize I wasn't setting it. So what we can do is we can process our dash here by just saying, okay, if dash is available, mana is over 10, is dashing is true, update our mana timer reset, and then let's go ahead and say velocity dot x is equal to dash speed times facing direction dot x, and then let's go ahead and duplicate that and say velocity dot y is equal to dash speed times face direction y. Now you can either do it this way, or something I'm going to start doing a little bit for you guys is I'm going to teach you about compacting your code. And some people like to do it and some people don't. So you could also do velocity is equal to new vector 2 dash speed multiplied by facing direction dot x comma dash speed times facing direction dot y, and that would achieve the exact same result in a single line. So it's up to you guys on which one you guys prefer. Some people prefer one way, some people prefer the other way. So now if I come over here and I hit play and I run, I hit shift, you'll notice that it kind of worked, but you'll also notice that weirdly enough, I'm kind of just, A, I'm floating, B, I just keep moving in a weird direction, and if I hit shift, I just keep walking, and it's really kind of funky, right? And I also just keep taking damage, and everything's just kind of broken, right? Well, the reason why is because A, the user can put input, which means as soon as this runs, it's going to go and grab player input, and the player has left and right pressed, right? So since they have left and right press, their current state is player running, right? So they go to running state, and then they move over to the idle state almost immediately after, right? So that's a problem. So what we need to do is we need to go ahead and do a little bit of coding against that, right? So we'll go ahead and pause some input. So we'll say private bool pause input, and we'll go ahead and default that to false. Well, it actually defaults to false already. And then we're going to come down here and say, hey, if not pause input, then go ahead and do input manager. Now, this is another part of code compacting that you can do. You don't actually need curly braces if your if statement only has one thing. So this is something that you can actually do. It is valid C# code. So now what we can do is we can come down here and say process dash pause input is equal to true. All right. So now if we come back here and we dash, there we go. Now you'll see that the player is moving forever. So that's a problem. So what we need to do is we need to reset our dash timer. If you remember, we do have a dash timer that exists for this, right? Dash timer. So what we should do is we should create a function to kind of handle that, right? And this function is going to handle all of our timers. Simple enough, right? So what we can do is we can come up here to somewhere in our code and say, actually, I think I'll put it right under input manager. Private void process timers, and we'll go ahead and pass in a float delta. And then this is where all of our timer code is going to be. So if you remember, we have our is dashing code, right? So if is dashing, then we need to go ahead and do our dashing timer, right? If is dashing this, right? And as a matter of fact, we could probably pull most of this and just paste it in here. So we'll just go ahead and grab most of that and we'll go ahead and paste it right here. And that'll give us a lot of that flexibility and give our dashing stuff set up, right? So you can see we have if our is dashing, blah, blah, blah. But what we could do is if we wanted to, we could say, okay, if player state is equal to, if current state is equal to player state dot dashing, then do this code. And then if dash timer becomes 0, then player state, or then current state is equal to player state dot idle, because we know the player is now idling, right? And that gets rid of our need to do our dashing, right? Now you can see here we have our process gravity here where we're doing our gravity stuff. I think it's probably a good idea for us to get this out into its own little function here, right? And what we can do is we can just pull this out because this is completely unnecessary, right? And this is like our climbing code. So we should probably refactor this hardcore, right? So what we'll do is we'll just pull this little bit of code. We'll control X that. And we will come in here and say private void process gravity. And we will go ahead and paste that code in there. And we'll pass in float delta. And we need to go ahead and set this to run at some point in time, but we don't really need it to run in our process timers because our process timer is more for processing timers, right? So what can we do? Well, we can pull this and just bring it up here and just say, hey, process gravity. Simple enough, right? And now that we have 2, we need to go ahead and re-add our curly braces in here. So sometimes it's just worth having your curly braces in here in general, right? But what we can do now is we can go ahead and let's look at our process timers. Current state is player idle. And we can actually change our... I know this is kind of confusing. I'm sorry, guys. Let's see. When this happens, pause input should be equal to false. That'll handle that. And we don't need this climber timer to run unless the current state is climbing, right? So if current state is equal to player state dot climbing, then we can go ahead and run our climbing code. And now we have some issues here we got to figure out. Let's see. I need to go ahead and add in an open brace here like that to clean that up. And I think we'll keep this for right now. Yeah, so let's format our document a little bit, make it a little cleaner. There we go. And I think that will work. Now we do have process gravity, so when the player's dashing, it should allow us to process gravity now. Which means we might need to change that a little bit, but oh, it still doesn't quite like us. So let's see, something's wrong. So let's take a look at it. If current state is equal to dashing, dash timer. I didn't get any ghosts, so I'm going to assume that none of this ran. Let me see, process dash. Let's go ahead and run this and take a look at it. Let's do some debugging here. And like I said, a lot of this refactoring is more of an art than an actual science here. So it's kind of just you messing around and trying to make sure things work well. So I come here, I do my move and slide. I do my physics process, which this is something completely different. So let me come up here. Oh, I'm not processing my timers. Duh, that's why. Oh my goodness. I'm sitting here like, I don't understand why this isn't working. But I need to process my timers. So let's come here and go process timers. Let's pass in delta. There we go. And now if I go ahead and I attempt to run this and I dash, you'll see that everything seems to be working for the most part. Other than it looks like something's not getting reset when I do my dash. So let's take a look at it. So after my first dash, everything works. I don't need this is dashing false. Current state is idle, which is fine. Our pause input is false, which is fine. Velocity is equal to 0. That's fine. Do I have a is dash available? Well, I don't care if dash, well, I do care if dash is available, don't I? I don't need is dashing. Is dash available is equal to false. If we come up here and check our state manager, dash timer is dash available is equal to true. And let's see if that fixes it. I think it's because our dash wasn't available. So now if I hit over dash, yep, that seems to fix it. Perfect. Cool. So now that it does that, let's go ahead and get our jumping system to work. So we got our dash, and actually let's make sure that our dash direction actually works. It should with our facing direction, the way that we're doing it, it should work. Let's double triple check. So let's hit up, dash. There we go. Cool. So that all works just fine. Awesome. So now we just got to get our jumping working. Now, you could make jumping a state if you wanted to. However, it's going to be hard to juggle that state. It's going to be really hard to juggle that state. So instead, what we should do, or at least what I'm going to do, is I'm going to come down here where my dash is, and I'm just going to say, hey, if input dot is action just pressed jump, then let's go ahead and do some checks. I know that it's not ideal, but we're going to need to do a little bit of checking. So if is on floor, then we need to go ahead and allow us to jump. So we will make a variable here called jumping. So let's scroll up here and go private bool jumping, and we'll scroll back down here and we'll go ahead and say, okay, jumping is equal to true. Simple enough, right? Unfortunately, like I said, this one is going to be a little bit difficult because we don't want to go into some weird states and things like that. Now, the next thing that we need to do is we need to go ahead and check if we are going to wall climb, because wall climbing is important for this. So what we can do is we can say, okay, first, if you look at our code for wall climbing, I believe it is up here. It's a mess and a half. We're doing a bunch of ray casts here. Well, this is for getting items, but we're doing a bunch of ray casts here, I think, for it. Yeah, if we're doing ray cast is colliding, then we can do our jump. And then we can, if we can climb, then we can process our climbing, which down here, when we process our climb, I think we do some funkiness here where we're doing all this if statement stuff. And I don't like the way that it works, right? It's just funky and it's not great. So what I'm going to do is I'm going to check to see if let me see, go back to my input manager, if I can wall jump and if I can climb. Now, this is going to be fun. It's going to be interesting and you guys will find it fun. Since we have our jump here true, we can come down here and we can go to our movement code, which is process movement, and we can just call some jump code. So let's actually make a little bit of jump code. So we'll come down here and say private void process jump, and we'll go ahead and pass in a float delta. And we'll go ahead and just run process jump. And that'll allow me to process my jump code. So if the player is able to jump and all of that, they can just do it. Simple enough, right? So when we come down here and we process our jump, we can basically just say, hey, if jumping is equal to true and I'm on the floor, then I can go ahead and do my jumping. So jumping is equal to false, and velocity dot y is equal to minus jump height. And that'll basically allow me to do my jumping. Now you'll notice that I have is on floor. And then if I go to my input manager, let me minimize this, minimize this, minimize this. We're already done with process dash and idle and gravity, right? If we go to our input manager here, I'm already checking for is on floor. So let's go ahead and rip that out. I don't think I need that really. So we'll just do that. Maybe, maybe not. Who knows? It might break something, but we'll see. Because I'm already checking for it here. So that should work. That should work. Jumping is false. That's fine. Process movement, process jump. There we go. So that means that the player should be able to jump now. So if we hit space, nothing happens. It only does it when we move, you'll notice. So if I'm sitting still, nothing. But when I press over, I can suddenly jump, which is kind of strange, right? Well, the reason why is because we are in a different state. So if we look at our idle state down here, we're not processing our jump. So we're setting our jump to true. And then once we move, we jump, right? So we need to process jump here as well. And that'll allow us to process our jump code. So if we come back to here and we hit spacebar, now we can jump, now we can jump, and that's pretty much perfect. So next, now that I have my jumping working, we need to go ahead and set up our wall jumping. If you guys remember, we are able to wall jump. So let's take a look at that real quick. So when we did our wall jumping before, we went ahead and did some ray casting right here to determine if our actions are pressed, and we did some other funky stuff here where we did our velocity y and we did a bunch of is in air stuff and can't climb and all sorts of crazy stuff. Instead, what we're going to do is we're going to go ahead and in our jump code, when you press jump, we're going to set our state to wall jumping, right? Now, this is where some of the code is going to get fun, in my opinion. So what we'll do is we are going to check for a bunch of collisions and ray casts, and we're going to see if it works. So I'm going to do what's called compacting code here. So it's going to be kind of hard to follow. So we're going to say node obj is equal to get node raycast 2D raycast left dot, and I know I'm going to want to refactor this already, is colliding. And I'm going to go ahead and actually refactor this real quick. Hold on. I'm sorry, guys. I should probably have thought of this beforehand, but let me come up here and just go private raycast 2D raycast left. And let me just duplicate that and do raycast right. Because this is very inefficient and I'm not a fan of it. So let's do this. And then let's just come up here and go raycast left is equal to get node raycast 2D and do raycast left. And then do the same thing. Raycast right is equal to get node raycast 2D raycast right. There we go. And that's just going to give us an object reference here. So what I'm going to do is I'm going to go and say, okay, raycast left dot is colliding. Okay. And what I'm going to do is what's called a ternary operator. Okay. So this is a Boolean saying, hey, is this colliding? Right. We're going to go question mark. And what we're going to do is we're going to cast as a node the return object. So we're going to say get raycast left dot get collider, else if it's false we'll just pass back null for right now. Simple enough. So now we can say, okay, node obj is equal to raycast collider get collider null, right? And then we can say, hey, if obj is equal to null, then let's go ahead and do our next raycast. So we can say obj is equal to raycast right dot is colliding, question mark, node raycast right dot get collider null, much like what we did here. And that'll give me a, yep, you know, we're colliding with one or we're colliding with the other, right? And then we'd have to check one more time, right? If obj is equal to null, then we'll just go ahead and return. Obviously at this point it's null, so we'll return. Because we don't want it to do any more than this, right? Because there's nothing next to you. So from here we can just say, okay, current state is equal to player state dot wall jump, right? And then we can also say else current state is equal to player state wall jump. Okay, now this is really inefficient and not well put together code. Okay, and I'm not going to lie to you guys and say that it's good code and that it's well put together, because it's not. We can actually compact this a bit more and make it a little bit more efficient. So with the way that ternary operators work, it allows you to say, hey, if this is true, do this. If this is false, do this. Okay? So what if we just take this here, grab it, and then paste it in here? That is completely valid code. It's completely okay. And nobody, Visual Studio and C# will not get mad at you. So if we just kind of put these like this, which is standard for ternaries, at least where I'm at, we do this way. This is the exact same code as what we had. And if we just say if object is null, then return. And then we can just pull this like this. And now we have the exact same code that we just had in far fewer lines. Now, some people may think this is hard to read, and that might be true. That might be accurate, and I would argue one way or the other on that, and that's up to you guys to determine which one you guys prefer. But in my case, I'm going to stick with this for now, and we can go from there. Now, if I hit Control S and we go to our project here, I got a feeling this isn't going to work. So we're going to run over here. We're going to drop down, hit space, and it seems to actually work pretty well, surprisingly. Okay, cool. Now you'll see if I jump, I can just kind of jump up walls, which is a problem. And you'll notice also I can jump, which is not great. So first, let's fix the jump problem. So if I'm wall jumping, jumping is true, right? We don't necessarily want that, okay? So what we can do is we can bring back that old is on floor. So if is on floor, and that'll fix this problem. We can actually compact this. I'm showing you guys compact code. So that way you guys, when you guys see it in the industry, you're not lost, right? Because this is what you'll see a lot of times when people do C# is this kind of stuff. because it's compact and it's efficient and it makes sense to a lot of developers. Now, this is not faster or slower than doing it the other way, by the way, just to let you guys know. It's the exact same speed, just one's more verbose and one's less verbose. So this is just something to keep in mind. Now, that's the first thing you'll notice, is that jump was broken. So we just fixed it by reinstating this. Now, the next thing that we got to look at is our wall jump code. So let's take a look at that. And let's go hunt that down real quick. So process wall jump right here. So first things first, we're doing all of this, which does not need to be done, right? Because we're already wall jumping. Our state is wall jumping. We know that we're in here to be able to wall jump, right? So we could basically get rid of this, right? Because we don't need it anymore. We just need to check if we're currently wall jumping, right? We could just say, hey, if we're not wall jumping, then let's wall jump. Simple enough, right? Now, to do our velocity stuff, how are we going to do our jump? Well, what we can do is we can basically just say, hey, if our animated sprite dot flip h, then we can go ahead and set our jump. So we can just grab this bit of code and paste it in here like this. And then we could say else, do the exact opposite. Grab all of these guys. And this will achieve the exact same result in our wall jump as it previously did. So we can just grab all of this. We might need this wall jumping code. So let's grab that real quick just in case. And we'll pull this up. And I know like this code is a mess and a half. And I know we'll clean it up, I promise. So let me format my document, make sure everything is formatted nice. And we need to go ahead and check our wall jump timer. So let's go to process timers. And you can see how this makes it a little bit easier, right? All of our wall jump stuff will be in here, right? So if our current state is dashing, if our current state is climbing, if our current state is equal to wall jump, then we will do our timer code, right? So we might be able to just paste this and do this like this, because we know that we are currently wall jumping, therefore our wall jump timer would be going down. Now we actually might want to keep if wall jumping. I'm kind of, you know, planning on the fly here, guys, so forgive me, because we're going to want to check to see if we're currently wall jumping. I mean, granted, if you're in this state, it shouldn't matter, but we'll keep it just in case. So now if we come over here and we hit play, let's take a look at it. And we come over here, we drop, we jump, and you'll see that the player is now wall jumping forever. So that's not great. So let's see what's going on. So that means that somewhere in our process wall jump, if I minimize all this, if we're not wall jumping, wall jumping is true. Velocity, yup. So this should work. Wall jumping is true. Yup. And this is getting called by our process wall jump, which is fine. If I come up here, if is wall jumping timer, wall jump timer is equal to reset. Let's see what our wall jump timer actually is. And I know you guys are screaming at your screen about the current state thing. Don't worry, it'll be a switch in a minute. So wall jump timer is equal to wall jump time reset. What is this considered? Let's see. And I'm sorry, guys. I know that this this tutorial has been all over the walls, but the reason why is because it kind of has to be. 0.45. Okay. So it's calling it because our state did not get reset. That's why. So once this happens, we need to reset our state. So we'll say current state is equal to player state.idle. The player is now back to idle state. So now if we recompile and try this again, I have a feeling that this will fix it. So we'll drop, jump. There we are, simple enough. Now, you'll notice that our animation is getting locked here to whatever we want, which is a problem. So we're going to have to figure that out. But what we can do is we can either do the animation play here to override our animation, or we should be able to come down here and do it here. Actually, we could probably just do it here. I believe we were doing a jump animation, if I remember correctly. Yes, it looks like that gets ran no matter what. So we'll go ahead and come in here, process wall jump, and play our animation jump. And let's see if that works. That looks like that works. And as soon as the player lands, they go back to their standard state. Cool. That works. So now something that we got to check is eventually we're going to need to fix our jump state here. So we're going to have to figure that out. My guess is what I'm going to do is under process movement, when I do my animated sprite run, I'm just going to say if jumping, then do our animated sprite run jump, and then else do our run animation. That might work. Let me see if that maybe works better. Well, kinda. Not really. So we'll have to figure that out. We'll figure that out. We could try changing this to is on floor. We could see how that goes. So if you're not on the floor, then you're doing a jump animation. Let's see if that makes it a little better. That's better. Now, the only thing that's a problem is if you hit space, it just kind of idle jumps, which is not okay. So we could probably do the same thing with idle. I'm not sure if I like that, though, so we might need to clean that up later. But, I mean, we're in a cleanup pass right now, so, you know, it works. And actually, we could probably just say and is on floor, like that. And that'll clean that up. And then we could probably just go to process jump right here. Do our animation player play run. I think what we have will work. So let's try that. I was going to try to be a bit fancy, but I don't think I'm going to be a fancy. So what I think I'm going to do is I am going to go ahead and just say if is on floor, then run my idle animation. Else, go ahead and run my jump animation here. I don't really like this, and we'll have to probably come up with a state machine for our animation player, to be honest with you. But this is probably the best that I can do with the thoughts that I have right now on it. Except for it doesn't seem to want to work, so that's always a good sign. Oh, I see, because I'm not on floor. Duh. Goodness. We'll get rid of that, and then we'll go ahead and play. And like I said, I know this has been a mess and a half, but that's part of refactoring. There we go. So that pretty much cleans all of that up. All right. Now, the last one that we got to look at is our climbing code. So what I'm going to do is first I'm going to go ahead and look at our process climb code and look at our input manager. I think we could pretty much get rid of all of this, by the way, at this point. So let's delete all of that garbage. There, nice and clean. Isn't that nice? And we'll minimize this and we'll say if player current state is climbing, that's our climbing reset. Our process climb, that's fine. If we look at our input manager here, you'll see that I actually don't have climbing in here. So let's come down here and say if input dot is action just pressed. And I believe I did climb. Then we're going to go ahead and say current state is equal to player state.climbing. Simple enough. Now we're going to need to do additional checks here. Although this might work already the way that it is, I'm going to want to clean this up a tiny bit because I'm not a huge fan of how it works right offhand. So let me jump and hit C, and you'll see that our climbing system actually works. Now, it actually still works perfectly, exactly how we would expect it to work. So that's cool, but I'm not a huge fan of the code. So let's take a look at this code. I'm basically saying, hey, if you press climb, then you're climbing, which is fine in general. But if we look at our process climb code, like, this is kind of a mess. Now, all these get nodes I'm not a fan of, which you guys know. I also have an if input and all of these things, right? So what we can do instead, I think, is we're going to go ahead and say, okay, raycast left, we'll just use our raycast left. Raycast right, we're just going to use our raycast right because that's why it exists. So we'll go ahead and do that. Raycast right climb, we don't actually have a value for that, like a variable. So let's add one in. So we'll come up here. And we'll go ahead and just basically duplicate these two. So do that. And then raycast climb right and raycast climb left. And then let's go ahead and set our raycast climb left and raycast climb right equal to, and I'm basically just going to get node that equal to get node that. And I'm going to come down here to my climbing code, and it's called raycast left climb, raycast right climb, which I'm not a fan, but that's fine. There we go. And that just cleans all of this up quite a bit. So we'll say get node raycast climb left, raycast climb right. And that just cleans all of this up. Now, the other thing that we should really look at cleaning up in our climbing code is how we go about all of this climbing. Okay, we got a bunch of is action press. We got a bunch of messy code. So what I'm going to do instead is I am going to go ahead and say, okay, get rid of all of this because that's junk. And we also have an additional one of those because I forgot to remove it. And we'll say, okay, if all of this, then velocity.y is equal to climb speed multiplied by my facing direction.y. Before, we weren't doing it this way. We were checking all those inputs and doing all that stuff. Instead, I'm just saying, you know what? We've already checked all those inputs. We did it up here in our input manager. So why are we doing it a second time, right? And then we're going to say, okay, climb timer minus equals delta. And then I'm going to say, hey, if climb timer is less than or equal to 0, then I'm going to go ahead and say you can't climb anymore. And I'm going to reset my timer. And I'm going to set my current state equal to idle. And that will clean up our code a lot, right? It'll make it way easier for the user to interact with our stuff, right? Now, something that we should look at is how is it going to affect if the player can climb? We might need to put that either in here or up here. Now, something that I don't want is I don't know if I want this in here because I don't want it to happen every second, right? I only want it to happen when the user I mean, I guess it doesn't really matter. It's going to happen regardless. So we should probably check if we can climb first as well. So we will say in our input manager, we'll say if the input is climb and we can climb, then let's do that code. And that should really clean up our code. So if we come in here and we test it and check it out, and we grab, we can go up and down just like before. If we hold for too long, eventually the player is going to fall. It might not actually. Yep, the player can no longer fall, so that's not a good sign. Good thing we tested it. So, is climbing, oh, well, I already have it up here, so I really don't know if I need it down here, right? Because I'm doing that here. So actually, I could probably get rid of this. I don't think that's necessary. And I wonder if that'll fix it. And like I said, guys, I'm sorry. I know that this is probably a mess and a half for y'all, but there we go. I wanted to show you guys, like, you know, how refactoring tends to go. Now we do have some more things that we can do to make this a little bit more efficient. And what I'm going to do is I'm going to first go ahead and compact a bit of this code. So if mana is this, then update mana. So we'll just go ahead and put this over here. So that's just a little bit more compacted. And then we could just say else if do this. And that'll compact that a tiny bit, just a little bit neater. And I'm going to instead do this as a switch. So we'll just say switch current state. And we'll say case space player state is dashing. Then we're going to go ahead and do this little bit of code right here. So we'll just grab this, Control X, tab, 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 paste, break. And then we'll say case. Then we can go ahead and do this bit of code. And then we can go ahead and do case. It's equal to wall jump. Then we're going to go ahead and do this little bit of code here. And then we will rip all of this out. There. And our state management stuff is a bit better than what it was before. Now, some people really hate switches for this. So, you know, your mileage may vary if you want to keep it like this or not. It's up to you. I'm not going to stop you guys one way or the other. You can keep it as ifs if you'd like. I just did a state or I did a switch because a lot of times people get mad if you don't do switches. Now, this could probably be abstracted into functions. So we could pull this all out, but I don't know if I want to do that just yet. And I mean, that's basically our refactoring. Everything seems to work. Now, there is a bug that we're going to need to deal with. And I mean, there's a lot of bugs that we're going to need to deal with because as with all of my tutorials, they're not all one giant, this is exactly how you do everything. They're kind of a learning experience for all of us, right? We do have a issue here. And one of them currently is with our take damage. So take damage is right here. And basically the player can take damage. First, the state is not player taking damage. So that's something we're going to have to fix, right? But when the player comes over here and they take damage and they jump, you'll see that they get hit up and everything just seems kind of funky. The player can run and touch stuff, which is kind of weird too. So how can we fix that? Well, the first one is by adding a state for player doing damage. So we'll say current state is equal to player state dot taking damage. And then we're going to do the same thing, but for death. So we're going to say, hey, player has died. And that'll allow us to kind of get some fancy code going in case we need it. Now, what we can do, because we don't want to call take damage if we're taking damage. I think I actually do end up calling it. No, I guess I don't. Okay, good. So we can say, okay, if the current state is taking damage, then let's do some special code for that, right? And what I'm going to do is I'm going to go ahead and go into my timer code. Let's see. Where is it? Process timers. And we will go ahead and say switch current state. State is dashing. No climbing, no wall jumping. Here we'll say case player state is taking damage, then I want the player to do some things. So the first thing is we need to allow the player to not have input, right? We don't want the player to be able to touch the player and move them around when they're taking damage. So the first thing we're gonna do is pause input, right? The next big thing that we're going to need to do is we're going to need to go ahead and stop the player from taking damage when they're already taking damage, right? So they're going to need some kind of damage timer, so that way they can't take damage more than once. So the first thing that we're going to need to do is we're going to need to stop the player from taking damage when they've already taken damage, right? So that means we're going to have some kind of delay time where the user's taking damage, so then they can't do any input. They can't do any, they can't take any more damage or anything like that, right? So what we can do is we can go ahead and add a damage timer. So we'll come up here, we'll say private int damage timer. We'll go ahead and set that to 0.3f, and then we'll say private float damage reset. And we'll go ahead and make that equal to 0.3f as well. So it just allows us to reset our timer. There we go. And let me see why this is mad. My apologies. We'll do a float, not an integer. And then from here, we need to go ahead and come down here to take damage and just say damage timer minus equals delta. And then we'll go ahead and say if damage timer is greater than or equal to 0, then we want the player to be able to do input, right? So we'll say, okay, pause input is equal to false, and we need to reset our damage timer. So damage timer is equal to damage timer reset. And then we need to set our current state back to idle. And then we're going to need to go ahead and break to finish out our little thing here. So let's format our document so everything's formatted nicely for us. And let's go ahead and set this up so that it works. Because right now we just have a damage timer that basically just sets our pause input. But our pause input isn't getting set when we take damage. So that's the first thing we have to do. So we'll come down here and say pause input is equal to true. And that will pause our input because the player is now taking damage. Also, you'll notice that we're doing a move and slide here. We don't need to do that anymore because we're actually already doing that. So we'll go ahead and do that because we do that every frame anyway. So we don't need to do an additional move and slide. It's just a waste of speed. And you'll notice that we're using facing direction.x. And we probably shouldn't do that because every frame we set our facing direction equal to an empty parameter here. You can see right here, we do facing director is equal to 0. So that's not a good thing, right? That's going to force when the player gets hit, they're just going to get 0. They're not going to get launched backwards. So instead, let's go ahead and set this to animated sprite.h flip h question mark 1:-1. And you'll see that we have a little error here because this needs to be wrapped wrapped into a little parentheses here. And that should allow me to go ahead and have that. Now, I'm going to go ahead and let me see. Since this is doing minus, I don't think we need that. I think we could just go ahead and do minus and 1, and that should just handle it. And I think I have an extra. There we go. That'll handle that. And I don't need any of this because that's just getting handled by the move and slide. And that should handle it. So now, everything's set up correctly. Let's go ahead and run this. And let's jump, get hit. And we're going the wrong direction, but that's close to what we wanted. So we'll change this like that. And instead of 500, let's do 100 instead. And let's see how that goes. So we're going to get smacked. Bang, player goes back. Can they move? No, they can't. Not while they're taking damage. So that seems to work. Good, good, good. Now, I'm going to mute this for now because I don't want current state to be dead right yet. I think we pretty much have everything working now. Yeah. So if the player gets hit, yeah, that seems to work. Now, their dead state is not going to work until we do that and we allow them to play their dead state. And then once respawn happens, their current state is equal to player state.idle. There we go. And that should do our entire player management system. So bang once, bang twice, bang 3 times, they're dead. Well, that's not what I wanted. So we could probably just either allow input here or we could do it with a timer section. I think we'll just do it down here. So we'll just say pause input is equal to false. So that way they are allowed to re-input in their stuff. So let's see how that goes. 1, 2, and 3. He's dead. And now he's back. Nice. Now I feel like there's a little bit of funkiness with our states here. I can't help but think that there's some funkiness here. I think it's an order of operations issue. Dash should probably happen after jump. And we should probably mutually exclusive some of these things so that they don't happen all the time. It'd be nice if I could do else ifs on a lot of these. Like these ones are fine, but like you can't jump and dash and climb, right? So we should probably do else if like this. Like that, and that would force them to not be able to jump. And we should probably also do with our dash, see if we can pause input. I'm curious if that's not set. So let's go ahead and find pause process dash. Let's see if we're pausing input here. We are, so they're not going to be getting anything special. So let's see if this works. You will notice that there is a bug here where the player is able to wall jump off of any object, which isn't a good sign. So that's something we're going to have to look at. But it looks like there's some state issues. Is it because of my wall jump? Yeah, I think it's because my wall jump timer. So we'll come down here to my wall jump section. And we will say if you are wall jumping, we'll say pause input is equal to true. And that'll allow us to pause our input. And then we'll come up to our process timers. And we'll do the same thing with our wall jumping, where we're going to say pause input is equal to false. And actually, we'll only want to do that up here. There we go. And that'll fix that. Man, we have a lot of variables here. We're gonna have to go through them all and see what we can pull out. 'Cause some of this stuff is stuff that I honestly like is wall jumping. We probably will never need again. Hopefully, right? But let's see. I think that'll fix that. And our ability to wall jump off of anything is not ideal. So how we can fix that is if we go to our input manager, my guess is where we're processing our wall jump, we're doing this collision thing. And then we're just saying your current state is this. I think what we should do instead is we should go ahead and say, okay, if you press jump, then we need to check if that object is the tile map or is something that is jumpable. Now, you guys can do it however you would like. What we can do is we can say if obj dot is in group, and then we can just say wall jump able. I guess A would be lowercase, right? Then go ahead and set your current state to wall jump. And actually, we could probably just get rid of this, right? So then that just goes in like that. And there we go. So now when we go into our game and we hit play, you'll notice that we're not going to be able to wall jump on anything, right? Because we're not in that group. So if we jump, nothing, right? So what we can do is we can go to our tile map here, go to node, go to groups, and just say wall jump able. I think that's how I said it was. Yeah, wall jump able. Add. And then we could do something like, whoops, we could do something like go ahead and grab our two platforms and let's add them to the group maybe, so we can make those wall jumpable as well. And then if we hit play, when we do our wall jump, you'll see that we can wall jump now. And if we somehow collide with these guys, I don't know if we're going to be able to be honest, but we'd be able to wall jump off of those guys. Now, the last thing that we have to refactor is our ability to interact with items. So if we come over to our items here and we hit enter, you'll notice that we can't pick up any of our items or talk to our guy. So what we can do is we can go ahead and open up our little player controller here. And we're going to have to add in the ability to interact with our stuff with our input manager. So if we go find our input manager right here and we go, I don't know, somewhere probably here, and we say if input dot is action just pressed, we can say UI underscore accept, and then we can go ahead and drop that in here and just say interact with item. And I think that takes an OBJ object. So let's go ahead and take a look at our code here for this. And if we look at our code, it looks like we're doing a bunch of ray casting and stuff like that outside of this little function here. So what we can do is we can go ahead and just do some of our ray casting up here. And then we could either pass in the object or we could do it in here. I think I'll do it in here just so that it's all just kind of compacted into one thing. So we'll say node obj is equal to, and much like what we did before, where we did that fancy raycast right here, let's just grab that and use it because it's a really decent little raycast thing. So let's just reuse it for our node stuff. So we can actually just paste that in here. And we can get rid of our obj interact with item, and you'll see that everything just kind of slots in and just kind of works. Now, you'll see we have our if our object is a pickupable, if our object is an NPC. We also want to make sure that if our OBJ is null, then we want to be able to return. And again, we don't necessarily need these. We can actually get rid of them just by doing that. And that solves that. It's just muscle memory for me to do it that way. Now we can go ahead and go back to our game here and run up and hit enter, and you'll see that we've picked up our object. And if we hit enter, we can talk to Bob. So that's pretty much it. Simple enough. So that is all of our changes with our code. And I know that this tutorial's probably a very long tutorial. I think it's going to be almost 2 hours long. So I'm sorry, you know, if you guys have sat through all of this. You guys can actually see, if I open up GitHub Desktop, all of the changes that we've made to our player controller right here. So you can see how much stuff we've actually added and refactored here to make our code way more readable and way more simple. And let me do one last check to make sure that there are no more references. So this one has 0 references, that's fine. And you'll see that everything basically has 1 reference except for attack. Let's see what my 2 references are just to make sure that everything's settled. Right, I see. So I'm going to keep that like that. I'm okay with that. 1 reference, 0 references, that's fine. And let's come in here and take a look at these guys. So we don't need our is and air anymore. We don't need our is dashing anymore. And let's take a look at some of our Booleans. Let's see if there's any Booleans that seem like it's something we could remove. This one we might be able to get rid of. Yeah, we could definitely get rid of this one now because we have a state for that. So we'll get rid of that. There we are. And let's see, public delegate death, that's fine. We have our references. We have a damage timer reset. Yep. So that's pretty much everything. Awesome. So if you like this video, go ahead and hit that like button. Hey, if you dislike this video, go ahead and hit that dislike button because I'm here to make content for you guys. This video wasn't really a viewer suggestion. It was just more of something that had to happen for us to make our game actually into a good game. But if you guys have any suggestions, please leave them in the comments below and I'll be more than happy to add them to my list. I am working on a pre-rendered tutorial for Godot and you know that should be released soon-ish. Same thing with the navigation tutorial for 3.5. You know, I always take all of your guys' suggestions very seriously. And hey, if you have any questions or comments on all of this code or tell me that I'm bad at coding, please leave them in the comments below and I'll be more than happy to talk to you guys. But that is all I have for you guys today. So thank you so much again for watching and I will see you all next time. Thanks.